In this video, we're going to be discussing basic blocks. Now, what is a basic block? Well, a basic block is a sequence of instructions that has one entry point at the beginning, so you can only get into it from one place, and it contains no jumps or branches except from maybe at the end. What does this mean? Well, this means it's a block of code that once it begins execution, all of it will be executed. So if any part is executed, all of it will be, because there's only one way in, and the only way out is maybe a jump that's at the bottom, or branch that's at the bottom. And why we're interested in these, well, compilers break down control structures into basic blocks. So we have this basic notion, or this atomic notion at the bottom here, of a basic block, which is just a stack of code that must be executed whenever it begins to be executed. So what does this look like? Well, let's have a look at a MIPS example. So how would we find out where the basic blocks are in this code? Well, remember, a basic block only has one entry point at the beginning, and it contains no jumps or branches except maybe at the end. So we can see this label L1 at the top here. This is an entry point, so a label is an entry point because you can jump to it. So you would want the basic block here to be just at the start of this label. And then if we look down the instructions, we can see that we've got load by unsigned, or set equal, and then we've got a branch of equal to 0. So that's where this basic block ends. So it starts at the beginning at L1, and it goes down to branch of equal to 0, because as soon as this, if we jump to that label, everything in there is going to be executed until we get to the branch. And it could be that we would fall down and do the add, and then the jump. But it could also be that we jump to label 2, so we don't execute that bit of code. So this, everything from L1 down to branch of equal to 0 is a block. Similarly, if we fall through the branch and the branch doesn't succeed, then we do add, jump. And that's another basic block. So there's two blocks in this code, because we would jump to L1 at the end, so there's a jump at the end. But once we start doing the first add, we then have to do the next, because the program counter will just increment. It'll just move on by 4 and it'll find the next add instruction. Then it'll increment again and it'll find the jump instruction. So here we go. You can see those are the basic blocks. Now you want to split before each label and after each branch or jump, because the label, if a basic block only has to have one entry point, then a label is an entry point, because we could jump to it at any time. You don't know where in your code you might jump to that label, but you could jump to it at some point. So we want to split there, because that means otherwise we might have multiple entry points into the basic block. And of course you want to break up each block after a branch or a jump, because you could wind up moving on, so you don't know that what's going to be executed afterwards. You could succeed in your branch, you could fail in your branch, so you would have two different outcomes, in which case we would have to split up the basic block at each jump or branch. So let's have a look at an exercise. There's some pseudocode up here. It's C style, but it's just as well thinking of it as Java style. It's not too different. And MIPS, so identify the basic blocks, assuming the result of the test is stored in T0. So we have while test, and then we have loop body. So again, remember, a basic block is a sequence of instructions that has only one entry point at the beginning and contains no jumps or branches except possibly at the end. Remember, we want to split before each label and after each branch or jump. So first what we need to do is convert this while loop into some sort of MIPS pseudocode, and then we need to label where our blocks are. So let's have a look at that. Well, we would have a label at the start, because this is a while loop. We test, we jump to the start of the loop every time we succeed in passing the condition. So we'd have a start loop label, so that would be the start of one block. We test, and then we branch if that is equal to 0. So you could see us using some sort of comparison operation in this test to say, for example, if a value is greater than or equal to 0, I set a value to be 1 in the T0. If it is true, set it to 0 if it's not true. And then branch on T0 to say if this is equal to 0, then we've failed our condition, or if we have passed our condition, whatever it might be. So we have our start loop, test, branch, so that's one block. And then we have the code that we'd actually want to happen if we don't pass the branch. So we fall down into what would actually be the loop body of this while statement, and we execute that code, and then we jump back to the start of the loop, and then we have the end loop. But there's no code at the end loop, so we don't need to worry about a basic block there. We might not exit gracefully, we might just let it fall off the bottom. But that would mean we have two blocks in this example. So we have one at the start of the loop, one in the loop body. Okay, so let's have another example of a for loop. So remember, with our for loop, we initialize values, we test, and then we increment, and we have a loop body of code. So we have to convert this into some sort of MIPS pseudocode, as we did in the previous example, identifying the basic blocks and assuming that the result of the test is stored in T0. So here's our example, the code of the sum squares, just if you feel like you need a concrete example. But let's have a look at how we would do this. Well, we have our initialization, we do that at the start. That's going to be our first block because we're just going to have some code that says, for example, load immediate value into v0 1 or set t0 to be equal to 0, whatever it might be. We do that before the code, before the body of the loop. Similar to the previous example, we'd have the test and our branching instruction at the start of the loop. We saw this in previous examples where we test at the start and then we jump from the bottom back up to the top. So that's one more loop, because remember we'd have to break at labels and at branches. So we start our block at the start loop, do the test, and then the branching instruction is the end of that block. Now afterwards, if we fail that branch, then we have the loop body, and then we have the increment instruction, and then we jump back up to the start of the loop. So again, this would be this would be a block, because it's as soon as you start doing the loop body code, then you have to do that, execute the increment or the step, and then jumping back to the start of the loop. And then of course the end loop is just a label, so we don't need to make that a basic block. But that's everything I wanted to cover today. The main takeaway is a basic block is really just a sequence of steps that once it begins execution must execute to completion. So a block, it just has to happen. Once it starts, all of it will execute, only has one entry point, doesn't contain any jumps or branches except maybe at the end. I hope you found this useful. If you have any questions about anything that I've covered today, please do let me know. Thanks.